This video will be on completing the square. We use completing the square to convert standard form to vertex form. Vertex form is written as y equals, or f of x equals, a parentheses x minus h parentheses squared plus k. Vertex form gives you your vertex, which is one of the reasons why we want to know how to put this into this format. Vertex comes from your h and your k. So we're going to take it from ax squared plus bx plus c and put it into this format. I have an example right here. F of x equals x squared plus 4x minus 12. What's really important to know is that in order to complete the square, your a value right now has to be a 1. If it is not a 1, you have to divide everything in the function by whatever your a value is. And then when you are almost finished with completing the square, you'll multiply the a value back into the problem to keep it the same a value. The first step we're going to do is we're going to take f of x, or y, or g of x, anything that your equation is equal to. We're going to change it to a 0 equals, or the equation equal to 0. We're going to change our f of x to a 0. So in this case, I'm going to put x squared plus 4x minus 12 is equal to 0. And since my a value is 1, I know that I do not have to divide it, and I can go ahead and go complete the square. Another thing you want to know about completing the square is that your b value, if it is even, it's going to make it a lot easier to be able to complete the square. The second step is to isolate the constant on the other side of the equal sign. The constant is the number that does not have a variable with it. X squared is your quadratic term, 4x is your linear term, and negative 12 is your constant. So what we want to do is take this 12 and move it to the other side. You move it to the other side by doing the inverse operation. Since it's minus 12 right now, we're going to add 12 to both sides. So I'm going to add 12 to both sides. I'm going to be left with x squared plus 4x is equal to a positive 12. Once this has been done, what we want to do is create a perfect square trinomial so that it'll factor to something that looks like this. A perfect square trinomial will factor perfectly, and that is why we moved our 12 over, so that we could have a c value that will create a perfect square trinomial. So step 3 is how we will actually create this perfect square trinomial. In the workbox, we're going to calculate half of b and square it. This is what it's going to look like. We're going to put our b value inside of here. We're going to figure out what that value is, and we'll put it into here. Then we're going to square that value, and we'll get a number out of this. Now, what's important to understand is that this number must be positive. This number must be positive. The reason this has to be positive is because you're squaring it. Whenever you square something, it'll become a positive. Whenever you square a rational, real number, it'll become a positive. So I'm going to create the workbox. It's just going to be a rectangular box. I'm going to make it look just like this one here. I'm going to have my parentheses divided by 2 squared equals parentheses squared equals something. We're going to figure out what this value is. So as of right now, we want to take half of b. So this is where our b goes into, because we're taking half of b. So our b value was the 4, not the x, just the 4. We're going to have 4 over 2. Now all this is doing is simplifying it in parts. So 4 over 2 is just 2, but it's still squared. I'm going to put this 2 value from 4 over 2 into here, so I can do each individual part. I've done the 4 over 2. Now I need to square it. So 2 squared is equal to 4. And this number is positive, so that is something that we've done correctly. The next step is add that value to both sides of the equation. We want to take this value that we just got and add it to both sides of this equation. So in order to do that, I rewrite this as x squared plus 4x, because that stayed the same, but I'm going to add the 4 to both sides. So I have plus 4 here equals, now I also have to add the 4 to the 12. So this will become, if I do 12 plus 4, because I have the 12 on this side, a positive 12, and I'm adding 4, that will give me a positive 16. Now again, the reason why we did this is so that this created a perfect square trinomial. Because the next step is to factor the trinomial. This factors nice and cleanly to become a perfect square. So this will come, when we factor this, we'll have a perfect square. The parentheses, that is not working. Have parentheses, and it will be something squared. So we want to factor this, and the reason why it'll factor nicely is because whatever our half of b was, whatever this value is, will actually go into here. Because we'll have an x plus 2. X times x is x squared. 2 times 2 is 4. But then when we have x times 2 and then 2 times x, if we were to write this out 2 times, we would end up having 2x plus 2x would give us that 4x. So a way to check this is to make sure that your half of b, this number right here, should be the number that you put into your parentheses. This is still equal to 16. We have factored this to a nice, clean, perfect square so that you can have your parentheses squared like it is in vertex form. The next step is to move the constant back to the other side of the equal. So we have a 16, and we want to move it back to the other side by either adding or subtracting. So since it is a positive 16, we want to subtract it back to the other side. I'm going to do minus 16, minus 16. Now this minus 16 is not inside of the parentheses with the 2, so it's going to stay on the outside of that parentheses. So we should end up with parentheses x plus 2 parentheses squared minus the 16 is equal to 0. Now the last step in completing the square is just write this function, write it as a function by changing the equal 0 back into that f of x or to the y or whatever it originally started with. So our problem actually started with f of x, so we're going to change it back to an f of x. Now generally f of x is going to be in the beginning of the problem and the equal 0 is at the end. So I'm just going to turn this back into f of x is equal to, I'm just going to rewrite all of this again, the parentheses x plus 2 parentheses squared minus 16. It is no longer equal to 0 because you can only have one equal sign in a problem. So we have written it back as a function. And you can see that this is in vertex form, the same way it was written up here. We have a parentheses x minus h squared plus k. Our a value is still in the front. Now the original a value was a 1, and our a value now is still a 1 out in the front. Our vertex, you would change the h value, because this is really x minus a negative 2. That's how we got the plus sign. So our vertex is at negative 2 and then negative 16. That is how you complete the square. You convert from standard form into vertex form.